Hello, welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift. We've come a ways and we've got a ways to go, but here we are. We're looking at operators as functions. So, in a programming language you're probably used to, the average programming language, you write 3 plus 4 for addition, and it's an infix operator. It's got a fairly low precedence, so multiplication takes priority over it, and so on. In Swift, in Elm, you can write a prefix operator. So you put the operator in parentheses, and now it's a function. And you can call plus 3, 4 with the usual arguments. You can pass parenthesis plus anywhere that takes a function parameter and things like that. You could curry it. You could call parenthesis plus 3 and then later on add, call it again with 4. You'd had a one argument 3 plus function. We're going to enable those capabilities. So where we are so far, we've we tokenized them yesterday. So when you have a parenthesized operator like this or string of operators, you can have plus 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 is a defined operator. We just tokenize it as one big operator. So it's a prefix operator with the string of its contents. And tokenizing it means we just understand it as character at the character level on the way in. Today we're going to work on parsing it, so making it so that when it's in the middle of an expression, we know how to operate it. All right, so let's bring up the parser and its tests. Oh, did it again. Now it's so ingrained, I always do it wrong. Okay. Let's see. So we're looking, I guess, at function call or defs. Excuse me. So we have function call or defs, which is expressions equals expressions. There's nothing in front like define function of xy equals something or other. You just say function xy equals. Well, if you go function xy, that could be a function call, and only when you see the equals do you realize it's a definition, and we have to take that into account. So we build up the expressions here, we check for errors, and then if there's an equals, we take the partial result and make it a function definition. Otherwise, we just return that thing, okay, as the value of the expression here, or as the parse tree of the expression. Okay, so let's go into expressions. We'll have to work our way down a little bit. Okay, so here's expressions, is one or more expressions. So parses one, parses more, while can start an expression. Okay, well, let's look in there. So can start says only certain characters can start an expression, and including int, float, names, parentheses, lambda, and if. The ones we have now. And we're going to add something new, so we're definitely going to be working there. Let's go back to expressions. Expressions. So can start, we need to know if you can start it, and then you parse each individual expression. Okay, because if you call parenthesis plus 3, 4, that's a string of expressions. So we don't have commas between arguments or anything like that in Elm. All right, so an expression, we gave ourselves a little breadcrumb there, in spite of my mostly anti-comment nature. It says, basically expressions can start with certain things, and if they don't, well, it's some sort of error. Okay. And in that list, there's no example of token of our prefix operators, which are perfectly valid and mostly work like lowercase names. So, all right. So parsing. Let's find a good place to put this. Yeah, we went around on this one a bit. Well, we'll just add it to the bottom. Okay, so what we're going to do is, I guess we're going to parse an operator expression, make sure it looks okay to us. Operator, what do we call it? Prefix operator, I guess we'll call it. Okay, so prefix operator parses as function call, I think. That's what we want. Okay, so we gotta check successful parse somewhere here. All right, the input, we'll do parenthesis plus 3, 4. And then the expected, I'll just move this down a little. Okay, and then the thing we expect, I think, is a function call. That's definitions. Trying to find a similar example. Well, let's just function call. Okay, so something like that. Okay, if we have 3, we're going to have 4. Okay, and it's not a variable. Maybe it is. I mean, normally you would make a function call. You would look up function in the symbol table, and it would say, "Oh, function is defined to be this," and then you would apply it to the arguments. So I guess I'm going to argue that this is our variable. I think that is probably what we want. We're going to pretend, in other words, we're going to pretend that parenthesis plus parenthesis is just a name like any other function name. And we're going to treat it that way when we look it up. But we're enforcing rules about how it gets applied. You can't just put an operator name anywhere you put a function, a lowercase name. You know, it's restricted to the front of the expression. And notice we could just, it would be legitimate to do this, but we're just going to do the whole thing. Okay. Function call, variable plus, integer 3, integer value 4. All right, that should fail. It would be amazing if it didn't. I think we'll get an error about can't start an expression with this character or something like that. Unexpected character. Okay, yeah, so it didn't think it was a parenthesis and then get confused about that because our tokenizing took care of that. But it's got an operator and it's like, I don't know what this is. But that's okay. We will make it work. Okay, so let's see. Can start. We're saying you can have a token.prefix operator. And I think I can just do that because I don't care what it is right now. Okay, and we'll just see if we're making a little progress. I think we'll get a different error message. Something like, I don't know how to handle this in an expression. Unexpected character at start of expression. Okay. Yeah. Line 1, column 5 is a little weird. All right, so let's let's take that one under advisement. Well, I don't know. It's not a legitimate. We shouldn't get that error at all. So I guess I shouldn't worry about why the error we shouldn't get is reporting the wrong place. I mean, 1, 2, 3, 4, 5 is at the 3. So yeah, it's just a little weirdness, I think. All right, let's find expression. Expression. Okay, so here's our tokens. Yeah, I think it's actually pretty similar to this. Okay, so this is token of prefix operator, and we'll get its name. Get token return variable of name. Can I fold those together? Well, let's see it work and then refactor. All right, now let's try and fold them together. Lowercase name. Oh, I think I can do this. I believe I've done this elsewhere. No. Must be bound in every pattern. Let's take this out. Oh, come on. Really? I can't do that. Case token operator. Is there anything else funny in what I've got here? Let's see. Name must be bound in every pattern. Case is already handled by previous patterns. I don't see why that should be an issue, but apparently it is. Okay. I'll leave it up here then, just because it's treated very similarly. I don't know. Let's see. So how would I look for this? Something about switch statement. I mean that passes, right? I don't know how to do a search on this effectively. So switch statement where two enums both have parameters. I don't know if that's everything I wanted to know about the switch statement. Oh, Microsoft. I guess I should put the word Swift in there somewhere, huh? Yeah, it's exhaustive. Enum, they don't have parameters on their enums. Yeah, that's a little closer, maybe. Okay, they're picking off values. Oh, I can do let in front of the whole expression. Oh, no, that doesn't matter. Huh. Oh, no, those are two separate. Oops. Case is pattern matching. Multiple patterns at once. Yes, that's what I want to do. Case with multiple patterns cannot declare variables. Okay. Apparently, it's not going to be happy with that. Oh, interesting. I've never done that. Okay. A little duplication that I don't see a good way to get rid of. Oh, too bad. And they're all similar in some sort of meta level, right? They skip over their token. Now that I could probably... Oh no, those can't. Yeah, I mean, I think it's good to keep the pattern that says you always start, with the next character ready, the next token ready. I was thinking maybe I could pull get next token up to the top, but different branches do that at different times, basically. I mean, it probably would be okay. I mean, I could rework these things, but yeah, it's what I call bad luck to do it, because you have a pattern you're applying, and then you start making special cases, and everything gets off kilter, and if you refactor, there's problems, whatever. All right, so at this point, let's run it. We got to commit it. I got to stop making that mistake. Okay, so I'm hoping I can call +34 and it gets an undefined function or something like that, because there's nothing in the system. It should parse, but nothing knows how to evaluate it. A non-function cannot be called. That message is a little wimpy, but okay. So let's go and evaluate. When we evaluate a function call. Okay, check in first. Parse prefix operators in expressions. Excuse me. Let's see. So when we call a function and we interpret it, evaluate it, we get the first thing. Okay. Don't we look that up somewhere? Result is expressions.0.evaluate. So that's the function to be, and expressions.0.evaluate is a variable. We just made it one. Okay, so evaluating a variable, you have a context and you look it up in the context. All right, and presumably operators like parenthesis plus are predefined, and they should be in the symbol table to start with. So let's find I guess we want our interpreter or REPL. Let's see, that's this. Here's the interpreter model. So here's evaluate. Interpreter.evaluate. Okay. And symbol table. Okay. Now, I'm not sure where we should set that up. I'm not even sure if the symbol table, if the interpreter should own the symbol table. I mean, it might be effective. Well, let's see. If we passed in the symbol table to interpreter.evaluate, here's a string, here's a symbol table, and somebody else maintains that thing, I feel like that might be a little better. I And then the other thing is, like, well, this symbol table should be pre-populated with certain things, among them parenthesis plus parenthesis, and any other system name, of which there's a bunch. We haven't dealt with modules or any of that stuff yet, but they're out there. Um, hmm. So I would like a way to initialize symbol table. I at least have to give it to the interpreter, I guess. Um, Now, what does a definition do? It adds stuff to the symbol table. Okay. So we could theoretically, well, if I want to do this with existing stuff, I could call evaluate with a definition of some sort and force it in that way. I guess I want to do something different. Yeah, how am I going to do this? Okay, so I could put something in the symbol table. That seems legit. So what I want to do is check that when I start with a brand new interpreter and I um, pass in parenthesis plus 3 4 and evaluate it, that should evaluate because the expression is already there. So okay, so I'm gonna do one slight change. It bugs me to have print before eval because it's a read eval print loop. um, read is our parser, so that's almost something separate too. But all right, so I'll just make that change as a simple refactoring. All right, so let's find an interpreter test. Well, interpreter has predefined values. And I don't know what we're so plus 1 2 is 3. We're not worrying about the type in this setup. Okay, and this test will fail. It'll get some sort of error message, right? We had that function, non-function cannot be called. Okay, good. Okay, so I'm gonna put stuff in interpreter. I don't know that it's the right place. We'll make it an init. So I think I could say, well, what's my define? Define. Evaluate adds a name with an expression. And so if I had an expression with an evaluate method, okay. So my initial thing is I'm going to just hardcore throw something in there, and it's just context.add. Let's make, we've got a brand new symbol table. Let's just do a symbol table dot add. The name is plus, and the expression, I'm going to start simple. I'm going to make, can I make a lambda for that? They probably should have found a prefix operator if there's such a thing. I don't know. Yeah, what I want to do is I want to have a primitive expression. And I really want it to be like lambda x, y in x plus y. Now there's no such thing. And I think I gotta change this. It probably should be a one argument expression. So I think what I'm saying is this in I don't know how you do a, can I do this? Is that legit? Yeah, I don't have primitive expression. I'm well, I want to make it, okay, I'm going to make a node. This may be a bad direction, but it's one of these where if I can stumble something in and get it in, I think it'll make sense. Hey, this stuff flopping back and forth. Because I did, oh no. I had my hopes up. Primitive expression. I spelled that wrong, I think. Primitive expression.swift. Okay. And then let's see, what's the most minimal one? Error expression, probably. Yes. Okay, we'll borrow it. And I'm alphabetizing these days. Okay. So primitive expression, we don't need a message. We don't need any of that per se. I'm going to say generic, or maybe I should say unknown. I just don't know how this is used. So I don't know. This is kind of one of these half spike, half development kind of things. I have no other message. I don't have location. I don't have. I'm going to say they're all equal for now, just to get through the cycle. As string, I don't need the location. I'm just going to say primitive. Okay, we'll have to do more on these. Okay. Primitive expression and it really is more like a function call, isn't it? Okay. Self. Function call returns result. I mean, I think we want to return. Well, we want to pass in a function of some sort, and we probably have to pass in. We have a context. So we're the predefined plus function. We want to evaluate something if it's there. Maybe we got to be more like a function call. Maybe this is a bad path. So a function call evaluates the first expression and gets some sort of expression, possibly a closure. If it gets a closure, and it has arguments, then we want to apply the argument to the closure. And apply the first argument, apply the function to the first argument. And that gives us back another closure, which we will apply again. Let's go to closure. Okay. So I most of you who've been here before have no doubt that I do these raw and live. So days like today, we're stumbling around a little bit. Okay, so apply a closure. You take the symbol table. We have an argument. Outer context, inner context. Okay, so our inner context, we add, this is for lambdas basically. It assumes it's got a lambda expression, so it's got a name. And so we want to add the name as the argument. So that would be the, well, in my thing, it's the x and x plus y. So I want to add the x, and then I'm going to call evaluate. Sorry, I'm going to call argument evaluate. So that's whatever the value, the first operator value. And then I assign it to the lambda. So if it's lambda x goes to lambda y, goes to, x plus y primitive somehow. Well, it kind of comes down to, do I want the lambda x lambda y part inside there, and the primitive is just is what? I don't know. It feels to me like wherever it got off to, that more or less feels to me like kind of how I want to do it. It you need the one argument form. This xn and yn is because you could just pass one argument to your parenthesis plus operator, your prefix plus, and then we would want to, if we had prefix plus 1 2 or prefix plus 1, and you pass this in and evaluate it, you should get a function back that is this. So the result of evaluating prefix plus 1 should be another closure or lambda expression. I mean, they're kind of related. I mean, we're giving it a closure that's x in that. We want to make sure the x travels along. So what is a primitive expression? Is it a closure? I mean, it's a kind of closure. I don't think I can do it at my lambda level, my expression level. If I had lambda with variable x in something, I don't know how I'd get the x back into the Swift domain. But somehow if I pass in the x and evaluate it with x3 or x1, I guess my example, then I should get a closure that's really lambda y in 1 plus y, the equivalent of that. And the y, oh boy. What I don't know, like, do I have to put another primitive expression in here? I just don't know how to get these domains right. Ugh. Is there a better operator to work with? I don't remember seeing a lot of unary operators in that list of operators we had. Let's go back to it. Got less equal, plus. These all take two arguments. Minus is the subtraction, not unary. Other operators, percent, star, arrow, that of shift, dot, dot, dot. Yeah, they all take an argument. Okay. Well, I guess we got to look at if function call, right? If we've set things up right, the function call applies. So the result is closure. If my primitive expression is a closure, we apply the arguments in its list. We will get back a closure of one argument, I think. Well, let's see if we can make this. I don't know. You can call this a spike if you want. it's a spike in a sense. Well, it's, I don't know. I'm not treating it as a spike per se. I'm just trying to, if it works, I want to claim it, but I'm not quite sure where it's all going. Okay, so let's find closure. Closures take symbol tables and lambda expressions. And then when they call, they know what to do with the lambda expression. Well, we certainly have a failing test, I guess. Non-function cannot be called. Okay. Primitive. I probably should just rename it to primitive, but okay. Cannot convert because it has no lambda expression. The lambda. Um, lambda expression. I'm just going to call it X for now. And symbol table. Wait a minute. Lambda is just name and expression. I don't know what it's going on about. The expression. Oh, I don't know what that is. I mean, it's lambda x goes to x of something. Well, okay, I'll just make it variable x for now. Cannot convert L type to symbol table. Closure. Oh, it does take a symbol table. Well, I think this is that legit? So I'm a primitive expression. I'm a closure. I act like a lambda x goes to x. Well, I have an expression just to keep things happy. I take one argument. That's useful. When you evaluate me, what happens? Closure. I build up a new symbol table with this argument in it. and call evaluate on your expression. Somehow, well, what I'm feeling is this. I don't think my primitive expression is a closure. I think I just want to use a default closure, but the lambda expression that corresponds to it, like maybe this should be primitive. And I don't know that it should be x. It's a primitive with a lambda x, and it's a primitive with a return value. Let's try something like that. Okay, so this is back to an expression, and his init is not going to be happy. Let's take elm type dot unknown. Okay, primitive, and evaluate the primitive. Well, what I'm saying is your init should take a something. Oh my gosh, it should take an expression. It takes a primitive of, well, how about a closure? I don't know. I'm going to mess my words up. I'll call it a primitive. And this primitive is a function from an expression to an expression. That seems good. Expression to expression. I don't know if that's quite right. We may need symbol table or something else. But that corresponds to what I did over in my initialization here. And okay, I just got to fix this word. And the file. So what I'm kind of saying is this should be a lambda expression. Is that what I call it? Yeah. A lambda expression with x and a primitive that. Cannot convert value of a string to never to closure result type expression. Referencing operator plus on sequence requires expression conforms to sequence. Let's see what my primitive looks like now. Primitive takes a function from expression to expression. X is an expression. I mean, I can parenthesize these, but that's sort of arbitrary, I think. That one, lambda add. Cannot convert value of string to never. Let's make this, I'm going to make this a wrong function. 1 plus x. Can I do that? argument type int. Okay. So much translation to do. Let's take a break. We're 2 or 3 minutes. We'll come back and see if that's enough to enlighten me. All right. See you shortly. Welcome back. Okay. Slight bit of clarity in my head here. This primitive is coming in as an expression, our interpreter level expression, because our function, our primitive takes a function of expressions and produces expressions. So I got to get those types straightened out. I think what I'm going to do, let's try this. Static plus let's make a method. Okay. And this method returns an expression. Okay. Well, how about we write this in Swift just to make things work. Okay. So this thing is going to be given an expression, and it's going to return an expression. Okay, so now that means that's something I can pass in here. Primitive of plus. Plus cannot use. Okay, yeah, whatever. All right, now plus needs a return value. Okay, let's return integer value 1, and we're going to see if we can get things water through the pipes, see if we can get things hooked up, and then worry about it. Okay, so I think what's going to happen is we return an integer value 1. We're going to get that same problem. Okay, let's make this integer value plus, and let's return, I may regret going so far, expression of y with primitive, my keyboard is killing me, interpreter dot plus 1, which is to be written. Okay, so now plus 1 is going to take y, where'd it go? I'll just keep a separate name just to be clear. How am I going to get x in there? Well, now I'm going to return my integer value. Okay. This thing I'll just return integer value 42. We haven't used that in our test. Okay, so now the lambda expression, sorry, the symbol plus, parenthesis, prefix operator plus, prefix plus, I got to say it that way, I guess. Prefix plus returns you a lambda expression that takes an x and evaluates interpreter plus. Well, that returns a lambda expression that takes a y and a primitive interpreter plus 1. I don't know how I'm getting there. Like somebody's got to give us a symbol table or something to evaluate. I don't know if I need another level. Oh my gosh. Sorry, this should be lambda. Lambda y goes to plus 1. Okay. Let's see if we are getting anywhere. Primitive. No, somebody's got to call. Okay. Let's just see where we are. Primitive is messed up. I return an error expression with error messages dot. It cannot happen. If I do that, do I need a location? Okay. If you actually try and evaluate the primitive, I don't know. I may let this bubble for another few days or something. Okay, let's see what this failure is. A non-function cannot be called. Well, I'm fearing that it's at that second level and not the first level. Okay. Am I doing something? Am I on a good track? That's hard to tell. So somewhere down in there, I got to get a function of 2 arguments that adds them together. I don't care if it digs them up from a symbol table. Is probably a legitimate thing. All right, so let's see. My function plus, you give it an expression, plus 3 and a blank, nothing yet. It gives you a lambda expression 1, primitive interpreter plus 1, but how do we get x in there? I mean, what's really going to happen is the symbol table is going to get, when we evaluate the lambda expression, the symbol table will get the x put in from line 22 with the value of the first argument. And then we'll call lambda expression of y with primitive interpreter of plus 1. But I don't know how we're going to get that x out. I also don't know if I'm one level too off or something. I got lambda x, lambda y plus 1. I mean, it's got to have access to the symbol table. Is the problem. And it can be the interpreter symbol table. That's fine, but let's go to the REPL a moment. Double check my understanding of things. So, all right. So certainly 3 plus 4 is 7. Plus of 3, 4 is 7. Plus of 3 is a function. Plus of 3 applied to 4 should be 7. Okay. So the reason I have this 2-level thing, it's that currying in action. If I just do a plus 3, prefix plus 3, I should get a lambda, the equivalent of a lambda expression, y goes to 3 plus something, or x goes to 3 plus. Now evaluate. I don't know. The plus. like somehow in line 17 and 18, I want access to X and Y, and as a function, I don't have it. Now somebody's going to call evaluate. Boy. Okay. All right, I'm going to say we're in full spike mode. We'll do anything at this point to learn something about this problem. And I will commit to reverting before I check in any of this. Okay, so that said, it's like, can I do this in the language, in the Elm language? Like, how far can I get? At some point, let's find the let's look for, I think, basic.elm. Is that it? Name basic.elm. Yeah, let's find this here. Okay, there it is. Elm stuff, mobster, static FP. Let's look at this one. Text made, okay. Well, that's not what I was expecting. We'll try this one. Okay. Well, I guess I need to get down to the folder it's in. Examples. I'm picking poorly. Okay, that looks like a real one. Show and closing folder. And he's only got that. Stuff. Well, that's interesting to me. I mean, we've got color, element, style. They're being referenced somewhere. No, this is really not what I want. In the Elm, somewhere in Elm land, I don't think it's these. No. Maybe I should look for a different one. Let's look for well, I don't know, color.elm. I don't know what these are. Let's go over here. I don't think there's a whole lot of Elm stuff. Okay. No. Well, what about online? looking for like standard types. Well, string's a module for Elm. Okay, that's great, but where are you? I forget, is there an info? No. All right, let's do this differently. Namestring.elm. Okay, showing closing folder. Okay. That's what I'm after. Oh, basics. Let's just see what we got. Exposing. We got these names. There's those infixes we don't support in general language use. Exponent, native.basics. Okay, let's find native. That's definitely the one I'm after. Okay. Yeah. I'm trying to do something like this, I guess. So they've got all these functions, native dot whatever. So native.basics.exp. Great. What else we got? Basics.tan. Yeah, there you go. Tan is math.tan. Okay, so yeah, this is their symbol table basically. So you define a bunch of functions and then you provide a map. And this map takes you down to a primitive function of one argument in this case, but potentially two. Yeah, notice like min, f2 of min. So that's kind of what I was trying to get at. Where's f2? Is that a JavaScript thing? But basically a lambda wrapper for a function like that. Or is that defined further down? I don't know. Did this include anything? Not really. JavaScript. No, maybe it's not. I don't know where that's defined. Okay, but at any rate, this is my analog to their functions. Yeah, so here's negate. That's an easy one to look at because it's a unary. And down here we should have negate somewhere. Negate. Okay, so if they ask for the negate function, you give them that function of one argument or a function of two arguments. But notice the two argument ones, they'll get wrapped with this f2 thing. And let's see if we can open that whole folder. File one source open. I thought that worked for them. Maybe not. All right, we can open something else in the neighborhood. Debug list platform. Program initialize. Yeah, I don't know where F2 comes from. Is that an inbuilt curry function for JavaScript? Well, there's that. So that sort of sounds like no. I wish I could get the directory name here. Oh, utils. Always look there, right? Okay, so let's look for F2. Oops. Only occurs in there. Where are we? Well, Codewhelm. Core 511 source. Okay. Yeah, that's almost exactly what we were doing, right? We had a function that x in y in, and then our function plus of xy, like that. The result of curry is a wrapper. Okay. Yeah, so currying is a transformation, so it translates f of ABC into f of A called with B called with C. It doesn't call it, it just transforms it. Yeah, so that's generic. Interesting. And the curried sum. And I think that's what that F2 is doing, right? It's saying this is a function of two arguments. Curry of F gives a function of A a function of B. Curry of sum. Well, I definitely feel like something like this is where we want to go. That you can pass in a two argument function, and it returns you a function that takes one argument, returning a function that takes one argument. Now, how do we get those values? Okay, but let's take this for inspiration. Okay. Maybe we can get a little progress here. Okay, so this stuff is JavaScript code. Okay, so can we define a curry function? Yes, we should be able to. I'm not sure the types. Well, let's start from sum. Okay, so I'll call it sum just to be compatible with them, and then we'll rename things. Sum of x of expression and y of expression yields an expression. Okay. And we'll return 42 for now. But we could get x and y. Okay. Right. And we want to define a curry function. And I'll call it curry 2 because it takes two arguments. Or it can have up to two arguments. I don't know. Let's see. If we do static function curry, and it's going to take a function of two arguments, both expressions. I feel like I got too many parentheses in here. Okay. You give me a function of expressions, and I'm going to return you, I don't know what. Well, what am I returning? I'm returning a function of one argument, which returns you a function of one argument, which returns you my function of AB. Oh boy. Okay, so it's a function of one argument, which is expression. Okay, let's pull this down. I'm going to violate the formatting a little bit here, I think. Okay, so this thing, expression, returns a function of one argument, I guess I do need that. And this function of one argument returns a function of one argument to an expression. Okay. Returns a function of one argument to an expression. Okay. Now we got to return something. Okay. What I think it's doing is I think it's returning x in y in function of x, y. You have a fix. I think I put the word escaping in somewhere or something. Non-escaping parameter function. Capture indirectly by this call captured here. Here being a little bit indeterminate, I guess. Okay, let's look up Swift escaping functions. I think it's at escaping. And I'm okay, let's cancel this. I think somewhere I have to put escaping, but I'm not clear from that where that would be. Optional functional parameter is escaping. No escape is only applied to a functional parameter by default. It looks like it's in the front before the arguments. Okay. Let's do a search on this specific topic in Swift. Swift curry function. Sorry, describe something that was removed. I don't know. Add a baby int to int. Oh. Interesting. Okay. Let's. Okay. So my assumption, I don't need to do this anymore. I can do x plus y. Well, I'm wishing I had strings now because I could throw x. I could get the values of the two x and y and then just print them. But we'll stop here. I mean, we'll stop here with the debugger. So, okay. So I think we've done something equivalent to this if I haven't messed up all the levels of things. But you have a function. I'm going to put them together like this. Okay, so you have a function. It takes two arguments, and it returns something. That corresponds to our sum function. What you get from the curry function then is a function that converts that into a one-argument function. The result of that one-argument function is a one-argument function. Now, how do we use that? Well, we want to say curry of some is the thing. Yeah, so curry of some is the thing going back to, I think, our lambda. I think I want to say curry of some here. Add interpreter. Interpreter curry. Cannot convert expression goes to function to expression goes to expression. Now maybe primitive should take. No. I feel like I'm just on the cusp of figuring this out, but I just don't know. Okay, so you've got a primitive function like this that really should be returning x plus y. Okay. You pass it into curry. And it gives you back a function returning a function. But a function returning a function, I mean, an expression is that. That's where I'm getting balled up, I think. Like this thing, a lambda is that. It's a function from an expression to an expression. And it's kind of what I was trying to do down here before was this. And I think what may be happening is this is in my Swift domain. Expression goes to expression. Now I don't want to get rid of this yet because I feel like it's got some insight that matters. But if this thing returned primitive of that, would that be legit? And then it would return expression. I think this matches that. Value of type nothing to closure. Okay. Function is type okay, the function definitely is expression goes to expression because that's our sum and we have to get down there eventually. All right, but what we're returning here, maybe we're just returning an expression. And I think that may be better. Extra argument. Expected non-void and return void. This goes outside. This goes inside. Is that better? Cannot convert return expression of type expression goes to primitive. Would that do it? We have a function that takes two expressions and produces an expression. If you wrap it in this and that, does it do anything? Well, what's failing down here? Curry cannot convert value of expression. So curry is producing an expression. This is not a primitive anymore. Okay. If we get to 42 without blowing up, that would be something. Okay, still not there. A non-function cannot be called. All right, we've been going a while. Let's take another break. Feels like something's kind of something close to something, but okay. We'll take that break. Okay, we're back. I just kind of have to talk myself from the bottom to the top, I think, or the top to the bottom, or however we want to look at it. I mean, if you see something and have suggestions, I'm definitely, colors are waiting kind of thing. All right, so somewhere at the bottom of primitive land, I expect a function like this that takes two expressions and yields an expression in the case of plus. And, one of these expressions really has to be either int, float, or number. Both of them have to be int, float, or number. And the result is going to be int, float, or number. Odds are it won't be 42 in the general case, but, that's the way it goes. All right. So I feel like this, modulo the contents of it, but from a declaration point of view, I think it's trying to do the right thing. It will eventually do the sum and return a value. And that's the kind of primitives we're going to have in our system for the predefined operators. So, just like the basics native.basics.elm stuff we saw that had those primitives, I'm trying for something very similar. I mean, it's a super common interpreter technique, that you have some primitives in the basic expression or whatever values you have in your language, and some of these are functions on those that you have some sort of wrapper that can call them, and then other stuff can be defined in terms of them. So we were looking at those Elm files like basics.elm, right? I mean, a lot of its stuff is just deferring to native.basics. But notice the declarations are in this. I don't know if there's anything that isn't delegating. Not seeing anything. But the point is there could be. Oh, here's something. Okay. Double less than g of f of x equals g of f of x. Okay, it's a function composition thing. So these functions are defined purely in the Elm level, but at some point you call a function that calls native dot something. That's fine. And that's very typical. And the nice thing about doing things this way is that you basically make it easy to extend it. You know, if you want to do code in your base language, then you're not interpreting that code. So imagine we had some sort of like heavy graphics thing, and when we want to just provide a wrapper around, you know, whatever the fancy graphics for iOS is these days. Metal, is that still a thing? Okay, whatever the graphics package, we could define something that passed the arguments into a function we wrote in Swift, maximum performance, calling these hyper optimized graphics stuff, rather than trying to say like, oh, let's move pixels around in Elm and it's interpreted so it's, you know, a factor of 5 slower, you know, 10 slower. Okay, here's curry. Curry takes a function of 2 arguments and going to a third and produces a function going from 1 to 2 to the third. Okay. Yeah. Okay. Never, just one more never. Okay. But at any rate, you know, it's very common that the system definitions for an interpreted language often are a mix of functions in the language, like these function composition ones, or calls to primitives, and then the primitives are written in the underlying implementation language. Okay, so we're standard on that. Okay, and this we have to deal with the types, you know, convert it to some numeric type to do the addition and so on, but it's okay. All right, so you know, to me, the structure of that is the structure we want. Now, this curry function we've got, we're trying to move things into the primitive domain, and without really defining what that means yet, so that's a problem. But a primitive is a something to do with functions, kind of like closures and lambdas. Okay, it takes as argument, it takes a function that produces an expression. All right, and so we're using that to say a primitive, the end result of our 2 argument thing is a primitive. The primitive is a function, it takes a function of 1 argument and returns it an expression. And so I guess if we go from inner to outer, primitive of y and function xy, okay. So it's kind of like a lambda in that sense. And maybe it should be a lambda in some sense. I don't quite understand yet. But what I think we have, I mean, this to me, you give us a function in our native domain, Swift, and we produce a function type object, a function like object in our interpreter structure. Okay. And then the question is, can somebody evaluate primitive passing in 1 value and getting 1 result? And the result is going to be another primitive, just like our closures return closures. Okay. And that's why I try to do it under closure at first. All right. But this to me, I don't know why lambda expression. Maybe it's just interpreter.curry. Well, it's lambda. Maybe not. Maybe this is what we want. I mean, this sounds more like what I'd like to say. Add the prefix plus. What do? You interpreter curry the sum function. And that gives you a thing that when you call plus gets substituted for the function. So primitives must act like something. Okay, because this thing, curry, returns a primitive. And when we evaluate the primitive, we should get something. All right, let's try. I did change things. Okay. I'm not expecting any function cannot be called. Okay, so a non-function cannot be called comes when when function call gets something back. So he says, I've got something that's not a closure. So maybe our primitives now should be closures. Okay, primitive is a closure. Elm type, this thing is something else. Oh, it's a lambda. Oh. Let's see. Go ahead. Yeah, symbol table and a lambda. I don't have a symbol table. I don't know if I need one. So let me just make an empty one. Well, this lambda expression is not what we want. That's the bad part. Maybe. Well, let's try it. Okay, he takes name and expression. I don't know, do I need 2 levels or something? Yeah, I mean, it's kind of funny. We hit these places. There's about 3 or 4 of them so far where it's just I don't have the guidance from the language definition to say what it means. I mean, the Elm one we saw, it's not. I mean, these functions, they just redefine them as the native function. Native.basics.degrees. Well, it comes in through 2 levels, right? So here's degrees, returns. Native.basics.degrees gives you this field, which is this function, returns a JavaScript function, which evaluates the thing you gave it. And I think one of the differences is they're sharing types, basically, that the Elm float type is really the same as the JavaScript native float. And so it's easier to convert. We have to do some actual conversions the way we're doing things. They just assign a function equals a JavaScript function. And that tells me they're probably turning their functions into a function wrapper around around their stuff. That is a JavaScript native function that's like interpret my stuff. Okay. So evaluate the primitive. See, I go back and forth. Should this thing be a closure or should it be a lambda expression? If this were a lambda expression, we could return a closure with symbol table and that. But you know, Clojure is snoopy about these lambda expressions. Maybe it shouldn't be. Maybe that's a sign of something weak in what we're doing. But like here, it knows name and expression. It knows it's got a lambda expression in it, and it evaluates that. I feel like we should inner context.add name. Yeah, and then we call expression.evaluate. Like somehow we should be able to delegate to the lambda better than we're doing. I almost want to delegate to the whole lambda, not just expression, but we're making this the closure's job, and I feel like it should be the lambda's job. Okay. Well, and then where's function call? He knows he's got closures. Okay. Golly. So if well, let's see lambda expression. How does he evaluate? Oh my gosh. Yeah, this is this boy. It's like Clojure and lambda are working each other. They're almost like a joint thing between them, and we're trying to inject something in the middle. A lambda expression evaluate. See, if we were a lambda, what would happen? We would say evaluate. We would override evaluate, basically. We have a symbol table. We would just say, we would call our primitive function with the argument given here, the lambda x, say. We would, well, oh boy, evaluate the lambda foo goes to foo. It's only when it comes back the closure gets evaluated in function call. Oh my gosh. You know, it's like I can see, well, I can see a problem or the problem, but I can't see the way out. There's got to be something simpler to do to evaluate these functions, and this is where I don't have the background with the functional languages to know what exactly that means. And you know, I don't want to like sit here and read research papers for an hour and let you watch me do that, but there's, I mean, Elm is kind of like this little subset of Haskell in some ways, And so if I found something that explained how Haskell does the evaluation of functions, that would be very nice. What my start in functional languages was with Lisp, and like the Lisp 1.5 book. It's got maybe two, maybe 3 pages, small pages of code that tell you exactly how do you evaluate a function in Lisp. Um, it's brilliant. Yeah, yeah, have fun. um, it's a brilliant piece of work, as far as uh, what the code is. I don't know if I kept that book. I got an electronic copy, and I might have gotten rid of my paper copy. But there's an eval function and an apply function. They work together to evaluate any Lisp expression. Lisp has, at least Lisp 1.5, has a pretty small set of primitives. You've got numbers, atoms, and that's about it. I don't even know if you had strings back in the day. Um, but it's very straightforward to see the definition, and you can see where, oh, here's how they peel apart the lambda, call the stuff, and do the thing. um, I haven't seen anything like that for the functional languages. I mean, I'm sure it exists, it's just not there. But the Lisp one was interesting. So they originally developed it with this very um, I don't know, more traditional kind of syntax in mind, and they called mexpers, and they used what they called s-expers, symbolic expressions. It was this parenthesized, deep parenthesis form that you're used to. The m expressions was a little more like traditional code, maybe not perfectly, but in 1958 there wasn't a lot of tradition, right? Um, so they defined this s expression thing and defined the interpreter in terms of how does it evaluate that. So they wrote code in their m expression language to evaluate s expressions, and then they well this guy Steve Russell, known as Slug Russell, I guess, um, looked at that. They were thinking of it as a mathematical exercise originally, but he looked at it and he's like, "Well, you've practically written the function. I just have to transliterate this to machine code, and write this, translate it into assembler, and your function that interprets things is now an interpreter." So he turned it from something that was kind of this theoretical mathematical thing into a Lisp interpreter code, and that's what they started with. And the garbage collector came later. I think they had like a couple thousand nodes was the maximum at one point. Um, and he's also the guy who invented Space War, which was kind of that first video game, at least first, I don't know, first one I know of, on the PDP-1. So same programmer from MIT back then. Um, I'm not sure how that helps, other than saying I wish I had a 3 page definition of how does a static functional language evaluate things. Bottom line is, I know I'm making it harder than it has to be, but something is right about this. This embodies this closure idea we had, that, well, not we, I mean, it's a long time existing, but it's the currying notion that says that if I have function of x, y, I can call function of x that yields another function of one argument, y, pass in that, and then do it. And that's this while loop. So as it evaluates things, it keeps getting down to closures, and which are one argument wrapped functions, basically, I guess we could say, with an environment attached. But as every time you peel off one argument, you return a function, and which is a closure, and then it says, oh, I should keep evaluating, and it's going through until it gets rid of all the arguments. And at that point, you may have a function that still takes arguments, or you may have a value, and either way is okay. Okay, so here we are. If it's not a closure and the expressions are not empty, so if we got to a value but there's still more arguments, then we get this error that we're facing right now. And maybe we should just, I don't know, I'm not sure if tracing down in here is going to help me or not. This may be a thing where if I sleep on it, I come out a little smarter, but all right. So the problem is, like at some point, okay, I don't want this, right? I want somehow I want to save my primitive. Okay, let's do that much. Um, let primitive be of type expression goes to expression. Okay, and save it. Okay. Okay. And then escaping, this is all about keeping track of what extra variables it's got to look for and stuff like that. Um, it's it's escaping in our definition of curry, so it's got to be escaping here, I guess. All right, now if you had this, like somewhere in here, I want this thing to be, I want to call primitive, but what am I evaluating, right? Uh, you know, it's it's got to have an argument, and that's where that stuff's going on in closure land. Okay, um, like somehow, somewhere, I need to call expression, and evaluate just doesn't have the argument. It's function call that's got the arguments, right? Function call is doing this work, and so I don't know. It's okay. So, like somehow I need this thing to get back to being a closure, so somebody will try and pass an argument to it, like this. Okay. So, if function is a closure, he applies the argument, the one argument, and gets something back. Right? So somehow, well, apply, right, is on a lambda. Right? Where's apply? It's on closure. That feels weird. And that feels like what I'm pushing against. Where's evaluate? What was our function for that? Evaluate. Why doesn't closure have evaluate? He doesn't. Oh, how weird. So he's not really. We never evaluate a closure. See, like I feel like this stuff belongs on lambda expression, and like the reason we need lambda name lambda expression is because we're doing this work on name and expression. But can we push this back to the lambda? That might be better, and then we could override the lambda. Oh boy. So I'm trying to think how we're going to take things back from the spike once we get it working, but we don't have it working, so what am I talking about? All right, so what I'm saying is I would like lambda expression to have its own apply. It's got an argument. That's a good thing. It's got the argument from the function call, and it's got a context symbol table. Lambdas need, the way you do a lambda is you assign the expression, the argument, to the name. So you evaluate the argument, assign it to name, and then evaluate the body of the lambda expression with that name already bound. Okay, this would be better on lambda. So let's see if we can get it there. Well, let's try it directly. Okay, and we're in spike mode and being ugly. I know it. I'm probably spiking too long, but I feel like maybe this is something that'll get us a step forward. So symbol table is not known. Is that context? Probably introducing subtle errors, but symbol table. Okay, we got 3 symbol tables kicking around here, maybe 4. Okay, so symbol table is the context when this closure was created. And that's the outer context. We're not using, oh, we are using context. So he needs symbol table. I don't know why I'm going to closure here. We return closure here. I don't know if we're messing up the way the lambdas have to, this whole bit about escaping and all that stuff, right? If you have free symbols in your lambda expression, the symbol table you got to use is the one syntactically wrapping it outside, and I'm afraid I'm making it not that if I do this. But that's the symbol table I have going into the evaluation. So I'm saying apply the argument in the context, and I've got the name, which is held, the expression is held, they're coming from the same place. Okay, I think that okay, if I just defer it in, can I make that work? So what if I said return lambda dot apply with argument and symbol table? Okay, so I'm going to do that. So what we've done is we've moved the original function back to the lambda. I'm still calling it through the closure, so I think the behavior, I'm hoping the behavior is unchanged other than that one failing test. Oh, can't even compile. Where are we? Okay. Primitive init. It is a closure. I think I want to make this a lambda. How many times can I go back and forth? I don't know. Elm type dot unknown. I think that's all we need for a lambda. No. Oh, string and expression. Well, error expression. I don't know. This is variable name. If it's optional, I shouldn't need to. Is it required? Oh. Missing parameter for argument 2. Okay. We'll just, again, I'm just trying to get it compiling. Okay, yeah, evaluate. Oh my. Well, I want to call primitive. Do I have the argument? What's... boy. Somehow I don't want the evaluate, I want the apply. I mean, the parent is doing... I'll let the parent override for me and just see what happens. I don't think I've changed much, but hopefully nothing. One test failed. Okay, that's kind of progress. Okay, so I'm deleting code that we are going to revert anyway, but we're going to keep something out of these lessons, out of this stuff. We may keep in this spike mode tomorrow. I don't know. Maybe we'll go back and undo this one. Okay, so who calls apply? Caller, just one place, and that's function apply. Now result is closure. Okay. So the lambda expression, we're in function call evaluate. He evaluates the left-hand side. That's a lambda. The lambda evaluate returned closure with the context and the lambda expression. Okay, we come back. We have a closure. We call apply. Well, okay, I can get lambda here, right? Let lambda equal function dot lambda. Okay. Is that... No, it's not used here. Okay. And I could try this. Now this is the switchover. I'm breaking away from that closure having the apply function. One failure. Okay. Let's go back to closure. So this is never called. These are never referenced. So much for that. Closure function call. I don't know who uses this. Golly. I think maybe it was left over from our spike. Yeah. Okay. Let me create a note. make a new note. Okay, so this is prefix operators in Elm interpreter. Okay, so I think one thing we can do is delete closure function call. Okay, because I think closure function call we created as part of kind of a spiky way of evaluating expressions, function calls before we really implemented it. And then we ended up with this closure function call mechanism separated. We said merge it into function call. I think we can just delete it. Okay. Another thing we can do is pull apply from closure to lambda. Okay. That's okay. We need this primitive subclass of lambda expression, and then the curry function currently in interpreter. All right, and I'm gonna capture that because I think that's kind of what I think I want. I think these things have something right about them. Oh boy. Okay, and let's delete this. Delete closure function called tests. Delete. Okay. Now build, test. Hopefully one failure. It's funny. I saw something go by in there. Maybe it was just a long line. Okay, that's kind of like progress. Lambda expression. He returns a closure context self. The closure keeps track of the lambda. Well, it keeps track of the symbol table too. I feel like we might be losing a little bit of something on this symbol table transition, but who calls apply is function call. Well, function call calling a lambda with an argument, that is really good. I mean, that feels right. And this thing could, I guess our lambda could return a closure. Expression dot evaluate. Where's my primitive? Okay. I think his evaluate well, let's take this. Primitive. I think this thing needs an evaluate somehow. Okay. And what we've got to do. Oh, I lost my apply. Okay, lambda expression apply is going to call expression.evaluate. I either return a closure or a value. Okay, and evaluate. Okay, I think I want to say no, there's something going wrong. Apply is the one that really does the work. What's the difference? Evaluate and apply. I mean, evaluate's giving it the wrapper of the function, but apply does the actual work. Okay, let's take this. Okay, that's a copy of what the parent, just so we have it. But, all right, so we get the context. And we build a new context with the name. Does the primitive have a name? Well, that's kind of... Well, somewhere, who knows where, like, I got to do something like let result equal primitive dot, as primitive is a function call, it's got to take an argument. Well, that's like odd. What are you doing here? Okay. Primitive is a function from expression to expression. So I need to pass in primitive of argument. Somewhere this should happen. Right? Because this is our plus function coming in. We have to call it. And we get something. Somehow we return a result. But I think we're going to do some analysis beforehand. Okay, this expression.evaluate, that's what we're doing. Why we don't need the symbol table, that's a little weird to me, but result is primitive of argument. That's the implicit x or whatever, our lambda is. Okay, and let's say if result is a primitive, I'm going to return a closure with context and result. Otherwise, I just return it. Oh man, close. Cannot return a value of type expression to the expected argument type lambda expression. Result is lambda expression. No, result is... Okay, well, I'm puzzled here. So what's the type of result? Is an expression. Closure, what does he want? A lambda expression? Okay. I know he's a primitive. Oh. I think I just have extra parens. Okay. I know he's a primitive because I just checked. So he's a closure. A primitive is an example of a lambda expression. So I can wrap the closure with this. I don't want the inner context because that was only created for the purpose of the primitive here. All right. Cannot convert value of type closure to expected argument. Closure evaluate. That seems, I thought I didn't have one before. Let's compare. I added evaluate. Okay, I'm going to take evaluate back out. I think I'm acting much more like a lambda, I hope. We might get 42 if we're really lucky. Oh, hey, okay. Maybe not totally luck, but an hour of stumbling around. Okay, so we've got 42. That means we got, where'd our interpreter go? That 42 came from here. Okay, let's change it to 21 and make sure it changes. I'm beginning to think closure is not a helpful class, but I think that's probably because I'm not doing something right. One failure. 21 is not equal to 3. Okay. Whew. I guess I'll take a last minute semi-victory. It's a victory from the sense of spiking. So we caught we caught some of this stuff. So primitive subclass of lambda. I'll tell you what, I'm going to leave the code as is. We'll do a little more thorough harvesting from it and make sure we know how to do this on the second round through. Then we'll revert and redo this and hopefully get it down to the right answers. But wow. It's like I'm in this kind of floaty place now after all that grief. But I'm still worried. I'm still worried there's something we're doing wrong with the symbol table and that the closure is necessary for that. It shouldn't affect the primitive stuff, but it might affect other things. So we'll keep going. But I think we're finding a path through there. So we got a little water through the pipes. Anyway, tomorrow is 1 to 3 p.m. Eastern, and I will see you then. Thanks for joining me, and take care. Bye-bye.